Hello and welcome everyone, all the audience, all the participants from different geography who joined this today's session. This session is AZ-204, developing solutions for Microsoft Azure. And this is our seventh and final session for this particular series. In past, we have delivered several series like Azure Fundamental, AZ-104, Administration, then DevOps, and this is the series on AZ-204. And in today's session, this would be the second part of this particular exam outline, that is connect to and consume Azure services and third-party services. This is our part two. Part one we have already conducted in our previous session. Now, before we continue, let me introduce the speaker for this particular session. Our primary speaker would be Ashish Raj. Ashish is a co-founder of this particular community. This is Azure Easy, who have delivered several sessions in past few years. And he is a DevOps architect as well as he is an MCT. Along with Ashish, we will have Sanjeev Panigari, who will help us to show the demos for today's agenda. He is also an MCP and a senior software program engineer. Okay. Now, with this speaker introduction, let me tell you a few more things about these sessions. So if you are attending these sessions, you have a chance, like you can win Microsoft Azure exam vouchers. Now, to win these exam vouchers, there are few prerequisites, like you need to appear on the quiz that will be conducted at the end of the session. If you appear on that particular quiz, we will be selecting the 6 people from that particular audience list who are appearing for that particular quiz in the next session. Okay. And all those 6 people will be getting one free exam voucher. Along with this exam voucher, you also have a chance to get one print copy for a book that is Demystifying Azure DevOps series. This is a book which is authored by Ashish Raj itself. Okay. Ashish, yes. So now, along with this quiz, there are a few more things that you need to be careful on that. Like to win this exam voucher and to win this particular book, you must have registered for the sessions that is available on Eventbrite. Okay, and for this particular session, generally we announce the winner in the next sessions. Okay, as this would be our last session for this AZ-204. So winner will be announced in our Telegram group. So you can join that Telegram group. The details for that Telegram group will be announced at the last of the session, as well as that is available on azureeasy.com. Okay. And with these sessions, if you think like this session is helpful for you, as we receive feedback from several people, like based on the session, these sessions help them to learn this Azure technology, as well as they are able to appear on the exam. They are able to clear the exam as well. So if you think this session is helpful for you, and this session should be helpful for the other people as well, okay, you can share that in the social media like LinkedIn, and you can hashtag Microsoft. This is Azure Easy. So as this particular session is organized by Azure Easy and sponsored by Microsoft for this exam voucher. Now from this, let me hand over this session to Ashish Raj. I welcome Ashish Raj to carry on from this particular slide. He will help you explaining the concepts as well as about the certification path from this particular slide. Ashish, welcome. Over to you.
Thanks, Vipin. Hello, everyone. Thanks for joining the session today. So as Vipin has said, this will be our last session in this series, AZ-204. After this series, we will be coming up with new series of sessions where we'll be covering a different aspect of cloud and mostly in the Azure. But let's continue for the session today. So today, as we start, Before that, let me share something, very basic thing about this exam that we are covering. So this is the exam we are covering, developing solutions for Microsoft Azure. And this exam will, if you appear for this exam, you are eligible for getting the the badge of Microsoft Certified Azure Developer Associate. So with this exam, you get this particular badge, which is essentially for any developer who are working in Azure. Now, with this particular series, as Vipin has said, we have already covered 6 sessions, and this is our seventh session in the sequence. And in that particular sequence, we have been covering different aspects of exam, and all these modules we have already covered. And the last module that we are covering today is connect to and consume Azure services and third-party services, which contains 15 to 20% of the exam weightage from the from the questions point of view of the exam. But we have also done all the previous sessions covering all other aspects, such as compute solutions, storage, security, monitoring, and all those things we have already covered. And if you have not been part of the session, previously, you can go ahead and watch all the previous session as well as slides on our website that is posted in the chat. So this is pretty much what we are going to cover in this session, and soon I'll be covering the agenda for that particular high level topic. Now, for this particular exam, as you know, this is a developer oriented exam, so there are certain prerequisites. Not in terms of any kind of advanced level knowledge that you require or a developer knowledge that you require, but if you are familiar with certain things which is listed in the slide, it will be helpful for you to relate with the exam. So as we are talking about Azure, so if you are familiar with the Azure ecosystem like as PaaS solutions and portal, it will be pretty much relatable for you, the concept that we are going to cover. If you are not familiar with that, then also we have covered it. So we have already done the AZ-900 session previously, which is Azure Fundamental, essentially which covers the point number 1. So if you are very new to Azure, we already have content for you. You can go through that and probably you will be already familiar with that thing. The second thing is that if you are familiar with the developer ecosystem or your role requires knowing one of these programming language, then probably you will be able to relate the concept or the topic that we are talking about in this particular exam. Of course, when we are talking about programming language, you should be familiar with the writing the code and all those things, or databases and all. And if you are writing an application or developing an application, then you must have come across situation where you want to authenticate with your users, you want to give some authorization, or you want to go through this, making your application more secure. So these are the basic things which normally any web developer or any developer will come across whenever he's developing a solution based on any cloud platform such as Azure. So this is pretty much a prerequisite for this exam. And if you are, if it makes sense to you, then probably this is the one exam that you want to go with, and we are going to cover all the aspect of it. So this is our last session, as I said, and in this session, we are going to cover these two topics. We are going to talk about event-based solutions, and we are going to talk about message-based solution. So what exactly event-based solutions are? When do you need those event-based solutions? What exactly events are? What exactly messages are? We are going to cover those services which are available in Azure for these particular topic. We have already covered the part 1 of this particular session, which is in which we have already talked about API management in the Azure, which is kind of part of this particular module. So again, if you have not gone through that particular session, you can always go to our YouTube channel or website and you can watch that. Now, coming to the topic today, messaging in Azure. More or less, when we talk about events or events or message, more or less they are similar in terms of if you're looking at from the very layman perspective. But when you go into the details, you get to know there are certain differences between them. And before we get into the services of Azure, which is going to help us for these different types of data, and that is messages or events. We will first try to understand a very basic understanding of these two things. What exactly a message is and what exactly an event is. So very simple, in a very simple way, a message is a raw data, and it has the it has the actual data. So when you are talking, messages, what do you mean a message? When one system sends something to other system, and when they communicate to each other, they communicate by using events, by using messages. Of course they can use events as well, but what exactly the main differentiator between events and message? The main differentiator between them is that event is a lightweight notification, so it just have the notification that something has happened. It doesn't contain the actual data. Actual data is contained with messages. So when you are designing a solution where you have these two different types of types of transmission of information from one system to another system, you have to first understand whether it's an event or whether it's a data, a message. Based upon that only, you will be able to figure out what exactly you can do with that particular thing and how to treat it, what are the services you have which can be used to achieve what exactly you want to achieve. So the very first thing is that the messages are raw data, contain it is actually the data itself. However, events are some kind of reference to the data. So they just contain the notification and the actual data is somewhere else. The events do not contain the data with it. However, messages do contain the data with it. That is the main difference that between these two things. When a sender sends a message, then it expects something to be done, something needs to be done by this particular, with this particular message by the target. So when a sender sends something, he definitely, he or she, the application must be sending it to some target, some destination. So when sender is sending a message, it has an understanding, it has an expectation from the destination place. However, in case of events or notification, it doesn't have any expectation. It might have expectation, it might not have any expectation. It's very much similar to your Facebook notification on your Facebook app that you get on your mobile app. So you get a notification, right? It's an event. But does it expect you to do something? It doesn't expect you to do something. It if you don't care, you just don't see that message, and that's it. But if you are talking about message, something like, when you are logging into your computer, it gives you a message that you need to re-log in to your computer, or you need to re-log in into your mail client, such as in Outlook in mobile. So it's a message, it's not just event. If you are not logging into the Outlook is not going to work on your mobile. So it does contain some message that has to be acted upon. So you have to take some action on it. That is the expectation that a sender have when it sends a message. But when it sends a notification, first of all, it might not, it doesn't have the actual data. It's just a notification. It's just a kind of a notice or an event that says that something has happened, this has happened, and it doesn't expect you to do any action. If at all some action needs to be done, then then the data must be provided, and when the data is provided, then it becomes a message. So this is a very, very different simple use case. When we look at Azure, these are the three primary services we have in terms of when we are using for some kind of messaging or some kind of event. So we have a requirement and we want to do something in different use cases. These are the most of the enterprise level what I would say services which are used in such programming, in such software building approaches, where you have an event or where you have a message. You must be coming across one of these services. There is one more service which is Azure Storage Queue. We are going to talk about that one in a bit, but these are the three primary one which you will come across whenever you are designing or developing a enterprise grade messaging solution. So let's talk about the first one, which is Azure Service Bus. So Azure Service Bus is a messaging solution which normally helps you in a in an enterprise environment where you have a lot of messages that you have to deal with, a lot of high value enterprise messages that you need to deal with. That's where Service Bus comes into picture. However, Event Hub comes into picture where you have a lot of big data kind of scenario. A lot of data is coming from different sources, and you want to handle that data in a particular way. You want to kind of ingest that data, put it somewhere else. In that scenario, Event Hub is the solution. And as it says, event handling. So if you have a situation where a lot of events are coming and you want to handle those events, not the messages, but the event only, you want to handle those events, Event Grid comes into the picture. So that the Event Grid is something that we are going to talk about first, just after this slide. But this is the one of the difference from the use case point of view. As you can see on the second point, it relates most of the time order processing, financial transactions. You have it. You most probably looking at Azure Service Bus. However, when you have some kind of telemetry, some kind of logging data, some devices are continuously sending some logs. Some applications are continuously sending some logs. Those kind of requirement will meet up with this Event Hub. In Event Grid, whenever you are doing some reactive programming, so what reactive programming is that you have an event, you have an order processing, or you have a some kind of a stream where one event corresponds to another event, and then the another event, the C event, corresponds to the another event, that is D. So if you have a kind of a stream of events that you want to kind of tackle, where one event leads to another event leads to the another one, and then in some places if some failure happens, then you go back and roll back all the all the events or all the actions that hasn't happened because of those events. In those scenarios, you will be talking about Event Grid, and we are going to talk about in detail how to use Event Grid, what are the main concept that you are going to talk about, and all those things. You want to control messages, Service Bus. You want to control what message should be going, what message should be consumed. You want to make sure that messages are consumed properly. You want to make sure that whatever the message is consumed, no other system should be able to pick that message and make a kind of a duplicate execution or duplicate transaction or something like that. Those kind of things you'll be doing in Azure Service Bus. As we say, it's a big data pipeline in case of Event Hub. So you have a distributed data streaming. You have a lot of devices. You have a lot of services which are continuously sending some kind of log, some kind of streaming, and you want to kind of accumulate that information in one place, and then you want to take some action on it. That's where Event Hub comes into picture. Event Grid is a kind of a push model where something comes here and then further something needs to be done. So it's a kind of push method. However, the Azure Service Bus is a kind of a pull model. So where you have to go to Service Bus, you have to ask, okay, give me give me those events that needs to be processed, and then Service Bus will be able to provide that, and then there will be a way to kind of make sure those messages are executed or are completed properly. So we are going to talk about all these things with this basic context now. So this is the start of our what I would say from the exam point of view. This is the start, I would say. Whatever the slides we have covered, those are very basic things which you are you might be familiar with, that what exactly messages are, what exactly events are. These are the three services which are primarily used, but in what cases and how to use it, that's what we are going to talk about. When we talk about Event Grid, this is a kind of architecture we are talking about. So you have something called event sources. Of course, first of all, we have something called events, and then we have something called event sources. And then these event sources are continuously sending some event and in between you have this event grid, and then event grids, are some kind of event handler are connected with this event grid using a particular thing, pub sub model we normally call, that is publish and subscribe. So these event handlers are some kind of services who takes action based on the events that has been sent by the event sources to the event grid. So event sources send some events on a topic, from this event source you get the event. From this, based on the topic, there will be a subscription by some service. Suppose there is an Azure function which will be subscribed to a topic A. So whenever an event is sent to a topic A, this function will execute its work. So event handlers are kind of a execution, or a kind of a systems who takes care of the action supposed to be taken if at all some event happened. So any event sent by an event source to the event grid on a topic is a kind of a publisher, a kind of a particular, you can say a collection, you can say a particular set of events supposed to be given to that topic, and then to that topic. So these event handlers are subscribed. So they are subscribed to those event handlers. Okay, whenever you get something in A, I'm going to take care of it. And that's how this event handler take action. So whenever something happens on a topic, the subscription gets activated. Subscriptions are aware of something is happening in a topic because they are subscribed to those topics. And that's when these event handlers are taking some action based on that. So, okay, something has happened, I am subscribed to this particular topic, I'm going to take some action. What action I'm going to take? Based on the subscription. So if Azure function has subscribed to this event, subscribed to this topic, Azure function will have some code, some logic that's supposed to run, and Azure function will run. Suppose, there are some other system like Service Bus or Logic App. We are soon going to talk about Service Bus as well. So Service Bus, these services can be integrated with each other as well. So something happens from the event grid, it has some event, it tells Service Bus, we have something, you need to take it further. And then Service Bus will take it further. How does it take it further? We will be soon talking about it, in terms of these, Service Bus, or in terms of event hubs. We are soon going to talk about this, but this is the way you have this event grid, where topic and subscriptions are kind of a publisher and subscription model in action, where any event handler can subscribe to a particular topic, and based on that subscription, if some event is happening, these event handler will take some action. Now you can define your own handles. You can define your own logic there, that okay, something is happening, I want to run this function which has these codes, or I want to run Logic App, I want to do some other things in Event Hub or Service Bus. You can go ahead and further do those kind of execution, and we are going to talk about certain things in a bit. So this is how this event grid works. Let me clean it up. So this is how this event grid works. Now, when you talk about event grid, and when an event, when an event is generated, this has a schema. So when an event is generated, event has a schema. And what do you mean by schema? Is that an event will have a particular data structure. In that data structure, more or less, these things will be same in most of the events. Subject, ID, event type. Event type, of course, it will differ, but event time, these things will be mostly, you will have some ID, you will have some subject, you will have some event type, and you will have some event time. The one thing that changes is the data. Data is, that is depending upon who is sending the data. So as we have seen on the previous slide, so these events can be coming from a number of sources. It can be coming from Azure Blob Storage, it can be coming from a resource group, it can be coming from a subscription, it can be coming from a event hub, it can be coming from Service Bus, or it can be coming from any custom event as well, custom resources as well, or sources as well. So from anywhere it can come, and based on from where it is coming, this particular data may change. But other than that, every event will have these few things which will be defining what is the event ID, what is the subject, and all those things. No, any event when it's generated in case of Azure Event Grid, any event when it gets generated, you have this limit that events are, right now this limit is something around, something around 64 KB. So event can have size of 64 KB. There is a 1 MB preview, so it is not general available yet. So the event can have the size of 1 MB, but it is in preview. But right now the general availability is 64 KB. So this is the limit that you have in case of this size of the event. And if at all you have more than that, if at all your event sources are sending events which has a size more than this, then you may get some error, kind of payload, payload is too large or something like that. And in that case, you need to figure out how to overcome that situation, whether you are using a correct solution for your use case, or you need to look at how to, kind of figure it out, this particular thing. But you need to make sure that whatever is coming to your event grid, it has to follow this particular size limit. As we have said, these properties are more or less same. The only thing which may change is this particular data, which is an object, depending upon the source of the event which is coming. These data version and metadata version are more or less schema versions, that is based on the the schema that you are using. It has nothing to do with any kind of specific event sources or any information related to event, but it is more or less a schema version. Now when you get an event, the event subject, this particular thing, comes with a kind of this definition, which defines what is from where this example gives an example of a storage account event, storage account blob file event, where a file is being changed or modified or something like that. Then your event subject might come like this, and then there is an example of it that suppose your container name is this, then this subject will have this kind of a definition, and based on that you can actually get to know that this event is coming from this particular container. If at all you want to filter out based on a file, suppose a.txt, you can do that as well. But if at all you want to only see the events in a particular container, this is how you are going to do. If at all you want to see all the container notification, then you will just stop the subject till here. And this is how your events subject will change and will tell you from where this event is coming, and how what are the levels of information that you can collect from this particular event source. This is how this event grid messaging works. Now, as you know, any time when one system sends information to another system, just in our case, there will be an authentication which will be coming into picture. Now, talking about event grid authentication, there are three things that comes into picture. One is a webhook event delivery. So you have a webhook way of validating the authentication, whether this particular event is supposed to be consumed by the other user or not, or other user is supposed to accept the event that is being pushed to it or not. So that is based on webhook. In that webhook, the first thing that you can do is you have a validation code where you can, if at all when the consumer who is supposed to consume the event if you have the access to source code of that consumer application, so suppose my application B is supposed to accept some event from Event Grid, and this application B source code is available to me, then there is a way to kind of programmatically access the token and programmatically, authenticate that. But just in case you have something like where you don't have the access to the application code. So suppose your application B is a logic app, or it might be a third-party system application. So logic app is probably, it is already integrated with Azure, so you don't really have to worry about the authentication part, because it will be taken care of in the backend, provided the user has the appropriate permissions. But suppose you are talking to a third-party service such as SendGrid or some other system where those services are coming as a SaaS component to you. They don't give you, Twilio, those kind of automation tools where you don't have access to the application code. You are just using a SaaS application where you're supposed to process the application, process the event which is being sent by Event Grid. In that case, you can use this validation URL handshake, where the URL does have a kind of a way to kind of authenticate whether these two systems are supposed to talk to each other or not. When you are talking about event subscription, when these two events are talking to each other, and when these two systems are talking to each other using this Event Grid system, in that case there are two types of topic that you get. Topic, as we said, whenever you are getting some event, there is a topic, that is topic A, and based on topic A there is a subscription. So subscription, suppose subscription small a maybe, and that is subscribe to A, subscribe to B, and subscribe to C. These are all topic, and multiple systems are keep on sending events to these different topics, and that is your event grid. So multiple systems are keep on sending the events to these topic, and based on subscription. So this particular application has a subscription for A, B, and C, all of them. Then anything which comes here will be provided to these guys, and that is how these topics gets created. So these topics are a kind of a you can think of a kind of a plan or something, where you go and you say, okay, anything happens to this related to this, I want to know. Your application is supposed to know. In that case, you can get to know all those things. Now these topics are two types of, there are two types of these topics. One is system topics. So system topics are more or less those topics which are coming inbuilt. So as we have said, we have seen that, I will again go back to that slide. As we have seen, there are a lot of Azure resources which can be event source, right? Which can generate events. Now, when they generate events, they're supposed to send it to Event Grid. Now, Event Grid is also in Azure, so both of these guys are on the same system. So Event Grid already has few topics which are specifically created for these types of event type, which is coming from a particular event source within Azure. So for example, anything happens on the blob storage, there is already a system topic, which says that anything happens on the blob storage, you need not to create a topic specifically. Topic is already created. You just say, I want to get subscribed to this topic. I want to get notified for this topic whenever something happens to a blob storage, and if Event Grid is getting that particular information, I want to get notified for that, and I will do whatever I want to do based on that. I want to run an Azure function, I want to run a logic app, I want to run something else, I will take care of it. So that kind of system topic which are already part of the system, inbuilt system, which is Azure Blob Storage, resource group, or any resources in Azure, those are called system topic. The other topic which are not part of the Azure. So as we said, there is a way to also create your custom event which is coming from a custom resource, or there can be something which might be happening on an Azure resource, but there is no inbuilt topic for that. There is no inbuilt system which actually recognizes that change. So in that case, you can also create your own custom topic. And in that case, you need to have, you need to have those particular level of access on those resources, access as in permission based on the resource we are talking about. So suppose you're talking about a virtual machine, you're talking about web app, and you want to get notified for something happens on the web app. If at all there is a system topic for that, you are already covered. You need not to think about anything. You just go ahead and subscribe to that topic, and as and when that change will happen, you will be getting notified, and then you can take action based on that. But suppose something get changes, but there is no inbuilt topic for that, then in that case you will be creating a custom topic, and for that you have to have a permission based on the resource we are talking about, whether virtual machine, whether web app, whether whatever it is, based on that. When we are talking about custom topic, when we said there are system topics, for example Azure things. So in case of system topics, since they are already part of the Azure ecosystem, Azure Event Grid is already part of the Azure storage blob, Azure web app, and they already have created the topic. So they already know how to talk to each other. They already know how to authenticate with each other. In that case, you might not be thinking about the authentication part separately. But just in case you are doing some custom topic publishing, so you have a virtual machine, or you have a web app, or you have a third-party system such as Amazon E3 virtual machine, or Amazon S3 storage account, or maybe Google Cloud virtual machine, or maybe Jenkins system build event, or anything, anything which is not part of Azure, or anything which is part of Azure, but there is no topic defined for that. There is no system topic for it. In that case, whenever some event happens, and if that event supposed to be sent to the event grid, then there will be a authentication supposed to happen. In that case, there are two things you can do. One is you can use a SAS token to kind of authenticate to your system, and the other thing that you can do is you can use a SAS key. So there are two ways you can generate a SAS key, or you can use a SAS you can use a SAS token, or you can use a SAS key to authenticate in case of custom topic publishing. So when you are publishing a custom topic to event grid, then there will be an authentication which will be required. In that case, these are the two headers which can be useful for you to authenticate to the event grid, so that they can accept, Azure Event Grid can accept the event on that particular custom topic based on the event that you're defining. And we are soon going to see how that happens on the code level, and then you kind of further take action based on the topic. So once you get the information on the topic, of course there will be some subscription to it, so you are subscribed to it. So topic is like, suppose you are taking a Netflix plan, or suppose you are taking a you go to our Azure YouTube channel, you go ahead and subscribe. When you subscribe, there is an option where you can click on that bell icon. So when you click on that bell icon, what happens is that there is a topic that gets created. First of all, there is a topic when we are giving that subscription button over there, that is YouTube is giving you that topic. When you are clicking on that particular subscription, particular subscribe button, you are getting subscribed to that particular topic. So whenever something happens which has been defined for a set of people who have subscribed to my channel, they should be notified for these events. That is of course defined by YouTube in this particular application case. So whenever any event happens, you get a notification for that. So for example, if you have selected that bell icon, then what happens that YouTube has already defined, if someone has subscribed to this topic, which is bell icon, that means if there is a new video published by new video event published by Ashish, then I need to notify in between. There is an event grid there. I need to notify all the subscribers which have clicked on that. So that is how this topic subscription model works, pub sub model that normally they call all the messaging system that gets developed based on different cloud platform. They have this particular methodology, and they all have different way of handling it. What we are talking about is we are talking about event grid, and this is how it happens. Now, when you are talking about events, when we are talking about events, as you have said, when you are subscribing to our YouTube channel, you can, in our case, in our YouTube case, there is no way that you can customize that subscription. You cannot say like, that if someone posted a comment, I want to get notified. If video is being posted, I want to get notified. If they are live, then I want to get notified. That is kind of filter mechanism for subscription is not available in your in case of YouTube example. But when you are using this event grid, then in that case, when you are subscribing to an event or a topic, then you can filter your subscription as well. What do you filter? You can filter based on event types. So whenever some resource write failure happens, some resource write success happens, I want to get notified. You can even get filter based on subject. We have already shared, we have already discussed this, subject like this, something is happening on the blob service default. There is a container with name container log, and there is a log there. So if something happens on this level, then I want to get notified, and you can further customize this particular subject based on your need. So and then they are saying that, something starts with this and something ends with this. So what we are saying is that any JPEG image event is happening. Some JPEG file is being uploaded, some JPEG file is being modified, some JPEG file is being deleted. This subscription will be notified for that. So this is a kind of a filtering mechanism you have in case of subscription, or you can have advanced filter as well. So what these advanced filter are, that one is that your resource type, the event type. The another is that based on the subject, where the based on the scope of the resource, where it is happening, right? Whether it is happening on the container level, whether it is happening on the blob level, or whether it is happening on the entire storage account level. And you can also go ahead and change the subject end with. So suppose you want to get notified for all the JPEG file changes, or all the text file changes, or all the other files that is being modified in that particular blob. You want to get notified for that the container, you can go ahead and get that particular filter for subscription, so you can subscribe for that. Or you can even define your custom advanced filter as well, where you can say, you can apply a operator where you can check a particular key, a key where it can say, that modified date, modified number of modification, or any property that will be based on the property, or that will be based on the resource that we are talking about. So based on that property, you can say that if that property number is more than that, then or less than that, I want to get notification. And this advanced filter that we have shown, one comparison operator. There are many operators, many way to kind of customize this, but we have just given one example here, that this is the way you can subscribe to. So what we have discussed so far is that you have a source. All right, this source is sending event to a topic. These are topic, and now you have subscribed to this topic. On this topic with a particular subject, either with the subject or with the event type or with the advanced filter. So it's not that everything coming into this topic you will be notified. You can even further customize the subscription based on the that definition that you are going to provide in terms of these filters. So that is how you can make use of the event grid messaging system in your requirement. Now, the next thing that we are going to talk about is Event Hub. So Event Hub is also very much similar. It works very similar to what you have this on the event grid, but there are little bit of changes here. If you see the major change here, you will see that it works, there are partitions here. So it's not that everyone will be talking about everything. There will be set of people who will be getting partition, who will be concerned about certain partition events, and there will be set of people who will be concerned about certain set of partitions. So we'll be talking about these different partitions in a bit. I mean, what exactly these partitions are. But first of all, just like we have talked a basic concept of things in event grid, very much similar things here in action, event producers. So just like we had these event sources in case of event grid, the name is only changing. Event producers are also the applications or the systems who generate events. Now, in case of Event Hub, it actually kind of simulate a Kafka system. So Event Hub also gives you endpoint such as, so suppose you already have a Kafka streaming solution. So Event Hub kind of solution, which is also based on Apache Kafka. So Apache Kafka, if you don't know, it is an open source alternative for this particular thing. So if at all you are using Apache Kafka, then you can replace Apache Kafka with this particular solution. Now, why to replace that? Since you already have it, Apache, Kafka solution, which works on a very similar principle, then why should we, replace that with that particular thing? The major thing is that as it happens with any cloud system, this is, any cloud service, this is also the similar solution. What it is that in case of Kafka, if you already have a Kafka system, you have to have the infrastructure in place. So you have to have a virtual machine, you have to have a cluster, you have to have a networking, you have to manage all those things. You have to kind of have an infrastructure in place to install that system, to make it working and all those things. However, in case of Event Hub, it is a PaaS solution for you. You don't care about what exactly behind the scene, which software is working, which operating system is there, how exactly the messages are being delivered. It's already on demand app level all the time, based on the SLA that you have, based on the subscription that you have, based on the capacity that you have subscribed to. I mean, very much similar to any PaaS service, but you don't have to manage any system, any server, anything on your on-premise system or anywhere else. So that is the major reason you want to replace this Kafka system, sorry, Kafka system. And now Kafka system, just like that Kafka system, you have those mappings available. So when you replace the Kafka system, you want to, your applications must be using already implemented system. In that case, let me just come back here. So in that case, you have this, not this one. This one. So you have these mapping available with the Kafka system. So if you already have a Kafka where you have configured cluster, you just have to replace this cluster with the namespace that you get. So when you deploy a Azure Event Hub, in Azure, you get a namespace. It's a kind of a container for you. It's very much similar to cluster in terms of Kafka. So all you need to do is wherever your applications are mentioning cluster this is the IP or this is the URL. All you need to do is take the URL of this Kafka namespace and you need to replace this that way. Or wherever you have a topic name, there must be some configuration where you will be defining the topic name. this is the topic name. You just have to go to the corresponding event hub, and you need to figure out what is the event hub name, and you need to replace that particular thing. So partition is same here. So whatever the partition you see on the event hub side, you just need to make sure that the partition numbering or the naming convention are similar to that. And similarly, all these other things, consumer group or offset, they are working very much similar. But what we mean to, what we are trying to demonstrate over here is that if you have this system, you can replace it with this system with all the mappings available. So you don't really have to do any significant amount of refactoring of your code, refactoring of your application. It's just that some configuration needs to be replaced, and that's it. Your event hub will be able to replace the existing system of your Kafka system. Now, talking about partitions. So as we have said, event producers are just like event sources. These event producers send event based on either HTTP or AMQP, which is messaging queue protocol, and HTTP is a normal web protocol. They send these messages or these events on these protocol, and these event hub is able to pick those events and can go ahead and further proceed. Further process it. Now, before processing it in the event hub, you have concept of partition. So partition is a kind of just like you have this, as the name suggests, it's a kind of a set of events which will be taken care by these partitions, and then the consumers who are supposed to accept those events will be kind of taking, if one system is taking messages from partition 1, then the other system, the other system will not be taking the events from the same partition. So it's a kind of a segregation based on partition. So some event goes to partition 1, some event goes to partition 2, some event goes to partition 3, some event goes to partition 4. So that way you do not really want to duplicate your events in all the partition, and then whosoever wants to use it from partition 1, they will consume it. Partition 2, they will consume it based on whatever the way they want to consume it, whatever the way they want to use it, based on the consumer group. So consumer group 1 want to use all the events from partition 1, partition 2, partition 3, or partition 4, or consumer group 2 only want to use certain partition events, not all the partition. So it's a kind of a it's definitely based on how you want to use that, how you want to consume your messages being sent into events being sent into the event hub. But it's a kind of a round robin kind of mechanism where events will be going to one partition, then the another event will be going to partition 2, and that way you are trying to make sure that the events are not being duplicated in all the partition. So consumer groups are those people, those receivers who are those group of people or those group of applications who are going to use it, and receivers are the actual receivers or the applications who are making use of those events and making sure that what's supposed to be done next. And we are going to talk about what exactly happens on the next level. Again, these receivers can accept these AMQ or HTTPS protocol. So that is how this event hub works. Very much similar, but little bit of differences in terms of protocol, in terms of partition. Now, in terms of event hub, there is a concept of capture. So what happens is that events keep on coming here. Events keep on coming here, and then there is a capture window which you can define. That capture window actually collects the event and save it on a Azure Blob storage or data lake storage. So it captures the information from the event hub based on the partitions, based on the capture window that you have defined, and then it saves those images, those events into the Azure Blob storage or data lake storage, and then can be further used by further system. So it can be Event Grid, or it can be Service Bus, which can take those messages, which can take those events, and can take action based on that, the way they have configured. But Event Hub will collect all the information. There will be a capturing window. The capture window will make sure that event must be captured in so and so time, and then they will be the events will be put into a data lake storage or a blob storage, and then further can be consumed in different application. When we are putting those events based on the capture, as you can see, they will kind of segregate those events with these kind of naming convention. These kind of naming convention. So you have this event hub, you have this partition, that year, the month, the day, hour, minutes, and second. When this particular capture happened, based on that particular capture will have this information in your data lake storage, and you can pick it from there, and then you can make use of it. Based on this hierarchy, you will be able to figure out what was the time when this particular event was captured from Event Hub. And these events are captured in Avro format, which is one of the Apache file system format, which is very much famous in big data ecosystem. So, and then this Avro file format can be further consumed by other systems such as Azure Data Factory, which can further understand the things which is inside that particular file and can do further processing or further work that's supposed to happen based on the things that you want to do with those events or those the data that you are getting from that particular event in Event Hub. As we have already discussed, so this Event Hub is a kind of a Kafka replacement in your system. So it can work together, but you can also completely replace your existing Kafka implementation without having to have a considerable amount of refactoring in your existing application which are using those Kafka systems. So all you need to do is just replace certain configuration. All these configuration mapping is already available here, which is there on the Microsoft document. We have already taken it from there only. So this is the very simple cluster namespace topic. Event hub, partition is partition, consumer group is consumer group, offset is offset. So these are the only configuration changes from an event hub to a Kafka system, or from a Kafka system to an event hub. So you can use interchangeably based on the system that you prefer in your ecosystem. When we are talking about Event Hub, there is a concept of dedicated Event Hub. So dedicated event hub, it gives you just as the name suggests, it's a kind of a dedicated cluster for you. So if you go with a standard Event Hub solution, there you have the capacity based on the throughput unit, and then you cannot, it will take some time to scale up, and all those things you have to do on the event. But in case of dedicated Event Hub, what you have is that you already have pre-approved or pre-dedicated, reserved, I would say, so capacity for yours. And then as soon as you start getting the events, your Event Hub will be able to process those events based on the capacity that you have taken. And this is very much useful in terms of big data solutions, or in terms of those places where you expect a lot of data, a lot of events to be consumed by your system. Another benefit that you get with this particular system is that you have many out of the box features, such as bring your own key concept, where you can bring your own key for kind of encryption, because there are messages going on, there are events going on. You might want to, even though it is fully secure from the Microsoft point of view, but still there are compliance needs. There are certain type of organization which will comply to a particular key, or particular key which supposed to be used for encryption. Those things you can manage. You can take care of OS updates, you can take care of security patches, so you'll be able to use those features if you are going with a dedicated event hub, because in that case Microsoft will allow you to give you the what I would say, a dedicated instance, and in that case it will not be a shared infrastructure in place, or some kind of a pre-approved or it will be a pre-approved, pre-deployed system where you can control certain extra things, just like I said, bring your own key, or whenever there is a scale up happening, you don't really have to pay additional cost, because as you have already paid dedicated instance for it, so you are already kind of eligible for using those capacities. It is a cost saving thing as well. So as you know, when you are requesting Azure for scaling up your Azure Event Hub or any service in general on demand, then what is happening is that Microsoft has to kind of keep it deployed, and they will have to give it to you as and when you require. Now, in that case, what happens is that if you do not require this particular kind of scale up or scale down frequently, then that on-demand things work well. That is definitely a kind of a system which you can use. But just in case, if you are using it in an enterprise environment where your use case is more or less more scaled up, where your application always need a higher resource, a higher capacity. In those cases, when you are going with a reserved kind of a dedicated instance where you are already paying Microsoft for it, then Microsoft is going to give you some discount or some kind of a cost benefit, because you are already telling Microsoft that, see, I have this much consumption trend, or this much consumption prediction, and I'm going to pay you in advance or something like that. In that case, Microsoft will definitely charge you less than on-demand thing, because it makes sense, right? Microsoft do not have to worry about those pre-deployed clusters. In that case, they don't really have to create on-demand and all those things. You already have it, so in that case they are giving some cost saving, if at all your requirements are like that. If you need such scaled up environment frequently, if you don't need it, then on-demand system is the thing that you can look at. Just like we have talked about Event Grid authentication, the Event Hub is also something that authenticate using a SaaS key, where you can use you can use you can create a SaaS key using this. We have just shared a kind of a snippet here, and the major thing that we want to discuss about, the main thing that we want to highlight over here is that you can generate a key using this this particular function method, and you can give authorization using this this particular way of methods, where you can say that these rights are send right and something like that. So these are some of the most important aspects when you are using Event Hub in a application. And of course, when we are talking about AZ-204, you most probably will be coming across requirement where you are supposed to authenticate with the Azure Event Hub in an application, most primarily .NET, or there are other SDK supports as well, but we have taken example of Azure, .NET here. So you can make use of these methods, and which are many times they may ask in the exam, they don't really ask you to write the method as it is or write the class name as it is. They will just give you some examples, and you need to kind of recognize the correct function or correct class name. This is the way of creating the shared access signature SaaS token. And when you create a SaaS token, this is a kind of a signature you get. So it is a kind of a common syntax here that they are talking about. So there will be a SHA 256 signature, there will be expiration time mentioned, there will be a key name mentioned, what key you are talking about, there will be a URI of the event hub. So that you will have this particular syntax of your shared access signature, which you can use for further creating the authentication with the event hub. When you are using event hub, the first thing you will be coming across with this NuGet package in case of .NET. In case of Java, there are other packages. More or less the names are similar. Event hub is the name that you need to remember. Microsoft.Azure.Event Hub is a NuGet package. When you install this, you get a class named Event Hub client, which you can use to create an Event Hub client object, which can talk to your Event Hub client using this create from connection string. So a small snippet of this particular approach is very simple. Here you have this connection string, which is a dummy connection string you will have. Here you will have the hub, event hub name, and this is the way you can create an event hub client using this create connection string method. So this is the these are the few of the most important method name that you need to remember. And actually, again, telling from the exam point of view, they don't really ask you to write the exact class name, function name, or method name in case of any resources. For example, because we are talking about AZ-204, then it is very important to understand this aspect from the exam point of view, that most probably they will give you three or four snippet, and you are supposed to recognize that correct snippet or the correct name. For example, here we have this create from connection string. They might have three options, where in one of them they will say just from connection string, in one of them they will just have create connection string, in one of them they will just have create string, something like that, and you need to figure out this is the correct one, and rest of them are just a kind of a distraction, a wrong number, a wrong name. So that is the thing that you need to remember in terms of talking to Event Hub from a .NET application. Now this is it from the event point of view. Now we will be covering the services which are more or less oriented towards messaging solutions. So far we have covered two services: Azure Event Grid, Azure Event Hub. These are mostly talking about the events, and we have already discussed in the very first slide what is the a basic difference between event and messages. So we have already understood events, how to handle those events. These are the two services which can help you in case of event handling, and we have already covered those Event Hub and Event Grid. Now we are talking about Service Bus. Service Bus is a solution which helps you interact with the messages. Now here also you might be seeing a lot of similarity in terms of terminologies when we are talking about these services. There are very slight differences between these services, and you need to understand that aspect in terms of basics, that those two services were talking about event. Now these next services, again two services we are going to talk about. One is Azure Service Bus and the another is Azure Storage Queue. Those two are talking about messaging solution. So you have a message, one system is sending a message to another system, and of course when we are talking about this, we have this sender and we have this receiver. Now in between these there is a collection, or there is a space where these messages are being accumulated. That space is known as namespace. Namespace is entire box here, rectangle, whatever you can say. This is a Azure Service Bus namespace. Now within namespace, you can see that there are different pipes, and they are called queues. Actually, we have this on the slide. These are called queues, and just like we have seen in case of Event Grid, here also there is a concept of topics. So topics, as we have said, here these queues are having topic, and it is not necessary to have topic here. It is just in a kind of a option here. So whenever something happens with this queue, whosoever is subscribed to this topic, they can get the notification. Or in case of service bus, these messages can be sent to the receiver based on FIFO model as well. So first in, first out. This is the guy who came first, as you can see. Then he will be coming out first, and whosoever is configured to accept this message, he will accept that message or receive that message, and they will take care of that message. This is the very simple way of dealing with messages with Azure Service Bus. In Azure Service Bus, you have both the concept, one is queue and one is topic. As we have seen in case of events, where there we do, even though during the Event Hub or Event Grid, we could see the logical queue over there, but there is no concept of queue where it will send a message based on FIFO, first in, first out. There was not like that. It was either based on partition or based on topic subscribe model, pub sub model. Someone has, there are topic, based on that topic, events are tagged, they have the topic ID on in the topic, and based on those topics, someone has subscribed to those topics, and then based on those subscriptions, they will get the notification or the events to them. Now here, what is there is that topic is there, it is available as a subscription, but in addition to that, you have this something called queues as well, where you can go to the queue, okay, and there is a way to create the queue client. You can create the queue client and you can get the messages out of that. To create a queue, you need to have you can create this queue client just like any, and just like we have seen this .NET application, .NET way of creating connecting with Hub, Azure Hub, Event Hub or Azure Event Grid. Similarly, there is a class named queue client which can be used to connect to the queue and then get the messages from the queue. When they are getting the messages from the queue, there are two receive nodes. There are two ways of receiving those messages. As the name suggests, one way of receiving the messages, receive and delete. So what happens is that you have this queue, you have this message, these messages, the sender have already sent that, and the receiver is getting that. As soon as this message has been sent to this receiver, this message has been deleted from here so that no one else can use that. Now another receiver will be getting this message, the next one, suppose this is 1, this is 2, and this is 3. So second message. So this is the first mode where as soon as this has been given to a receiver, this will be deleted from the queue. Now this is a very nice approach in where this receiver has the tolerance for message process failure. So suppose you have this message 1 has sent to the receiver, it has been deleted from here, right? So now it is not available here. Now this receiver somehow messed up with this message and was not able to complete the processing. Now the message is gone, right? Receiver 1 is also not having it. The queue is also not having it, the service bus queue. Then what happens is that your application will be not having any idea about message 1 anymore, because other receivers will be only getting message 2 and 3 and so on and so forth. In that case, this approach is not a good one. But if at all you are confident enough, or you have designed this receiver application in a way where they can tolerate the message execution failure scenario, then this approach is very good, because your queue is has not to worry about what happened to that message once this message has been given to the other receiver. Now the other approach is peak lock. What it does is that so in that case, what it does is So, as we have said, 1, 2, 3. In case of peak lock, what it does is it will send this to receiver 1, but it will not delete it, it will lock it. So lock it is in like it will not send to any other receiver, but at the same time it will be kept here in the system, and it will wait for a signal from receiver 1 that it has been processed. And the moment it will get a message, there is a a particular message which gets a complete async. So the moment it gets a complete async message, then it will delete this, and then it can be confirmed that yes, message 1 has been executed because receiver 1 has confirmed it has got the message, it has processed the message, and it has acknowledged back that message is completed. But just in case if message is not processed back, then in that case message is the first message is already there, and after a particular time, there is a duration that you can define. After a particular time, that message will be sent to another receiver or maybe to the same receiver for processing it again. That what, I have not got the acknowledgement that this message has been completed, please go ahead and process it again. So that kind of messaging you can do with this peak lock option. So receive and delete, as the name suggests, as soon as the receiver has received it, it will be deleted from the queue, and now nobody knows whether this has completed or not. In that case, your receiver must be tolerant, must be defined, must be coded, or must be designed in a way where it can cover the message loss scenario. But just in case you are not confident enough, then peak lock is the option that you can pick in that case. As we have said, there is another way of transferring your message using topic. So you can also create a topic client where you can subscribe to a topic just like you subscribe to an Event Hub or Grid, and you can get the message as soon as a message is being delivered with a topic name. And that is the way you can actually figure out what messages you want to get, what messages you don't want to get. As I have said, there is a way to create topic, then there must be a way to create a subscription as well. So that is all we are talking about from the code point of view. So these are all class names: topic client, subscription client, or queue client. So you create a queue client if you want to work in this particular approach. You create a topic client or subscription client if you want to work in a pub/sub model. Publisher, subscriber. That normally people use pub/sub term. Now this is the way to do this subscription. And there is also one thing which I forgot to mention, which is the last point, which is filter action. So you can also filter based on the action. So you can filter it that just like we have said in case of topic previously, you can also subscribe to a particular type of event with the subject. Similarly, here is also way you can do the filtering where some type of, so suppose you want to get a notification on all the files in a particular container, okay, but you only want to get the messages where the file is being deleted. So that kind of filtering mechanism is possible using this filter action. Routing and correlation. Now, what exactly this is in case of when your messages are being sent, there are ways to kind of messages can be shared either by one single client or multiple client. So the first thing which is there is simple request reply. So one message to one's receiver. Very simple. Similarly, as the name suggests, multicast request reply, where one message can be sent to different receivers, and they can actually kind of process those messages accordingly. Similarly, there is another option which is called multicast request reply. So what is happen is that when you send a message to multiple receivers, multiplexing actually. So when you send a message to multiple receivers, then in that case, what happens is that they can when the message is being sent to one receiver, two receiver, three receiver, each message has a session ID. Of course, every message will have a session ID. So when it goes to here, it can lock it until it process, and then only it can reply back to this sender, that is queue only, and then the other system can take care of the further action. So this kind of multiplexing can work in a way that you can make use of reply using the session ID, where it's not just only sending the message, you also want to get the acknowledgement as well, that what happened with this particular session ID, has it been completed or not. I mean, if it is completed, then according action will be taken and all. Similarly, we have one more thing, which is multiplexed request reply. So in that multiplexed request reply, what happens is that here you reply to a session ID. Here you have a queue actually. They call it reply queue. So just like you have a queue of messages, you have a queue for reply, and these queue will have all the reply coming from different system, and based on that you can further understand what session ID has been completed, what session is still pending, and all those kind of kind of actions that you can take care, so that you can figure out which session ID, which message having a particular session ID has not got the reply yet from any of the system, and we need to take further action, whatever you want to take, whether you want to send it again, whether you want to destroy that message, or you want to further send it to a particular client where that this particular client will always accept that message, and all those kind of things. So that is very much based on the requirement that you have, but you have the option where you can get the reply based on session ID, or you can get the reply based on reply queue. So it is again a queue kind of system, where you can say, just like message queue, you have this reply queue. The next thing, which is, they are very much similar to your service bus. The only difference between queue storage and, of course, the implementation will be different, but the major difference between the queue storage and service bus is, service bus is a very much enterprise level messaging solution. Queue storage also gives you a queue kind of thing. You have a queue where which is based on a storage account actually. So storage account, you might be already familiar. We have already covered a storage account session for this module, as well as previously in other sessions as well. So when you create a storage account, you get multiple services, right? You get files, you get blobs or container. People call it container or blobs, right? And you get queues, right? So when you get these queue storage, what exactly these queue storage is, that it is very much similar to your service bus what you have, and here also you have different queues, and based on the queues you can get some a particular queue, just like when you are referencing this incoming orders, you'll be getting everything here in the incoming order number 1, 2, 3, 4, 5, 6, 7, 8, whatever number is there. And then you can further process it, wherever you want to process it. You want to further provide it to another system, we're supposed to take it further and process it in inventory or anything else, you can do it. It is very much similar to your queue, the service bus system. The apart from implementation, the one difference is that there is no concept of topic. There is no concept of topic, right? You already have queue only. The second thing is that this storage is good for small requirement, right? So you have an application where you need a queue storage once in a while. You don't really need a queue storage for, you don't really have a big data platform or a IoT platform or a big scalable solution where a lot of messages are coming all the time and you want to have a queue storage so that you can load balance the processing of those messages into different systems. So you don't really have a big system in place and you don't really want to have a complex system in place. In that scenario, this queue storage works well with those once in a time queue storage requirement. But of course, there is no concept of topic. So you have to be aware that you cannot really subscribe to a particular thing. You have to take any, one message out of it, and then you have to filter it, programmatically, that what exactly the information that you require from that message. So you don't really have the filtering mechanism over here in case of queue storage. Talking about programmatically, you can also use this queue storage in a program using this queue client. So queue client is the method using which you can call a queue, and further there are different methods to get the message, to list the message, to delete the message, and so on and so forth. So we have not listed all the methods here. We just wanted to give you a kind of a introduction that this is how you want to kind of use the queue client in your .NET application. The major point here is keeping these snippets are that what exactly the expectation is from the exam point of view, that they don't really want you to remember this entire code. Again, just highlighting this particular aspect, all they want you to remember or recognize is that exact these methods or class name, so that when you are getting those method in a snippet, you are able to recognize those methods and you can tell, okay, this is the way you want to create a queue client. And for creating a queue client, you need a connection string and queue name. These kind of questions that may be asked when you are going for the exam. Now with this, we will go for a short break of 10 minutes. And after break, when we will come back, uh, Sanjeev will be giving us a very detailed demo from the from a .NET application, where he will be showing you how you can use an event grid in a real-time scenario and how you can make use of Azure Queue Storage in a real-time scenario on a .NET application, and how you can make use of this in a realistic way. Of course, it will be a demo application, but it will be a complete hands-on where you can be able to see the practical part of it. So let's meet after 10 minutes and we'll be on mute for 10 minutes. You can go ahead and take a coffee break or a tea break, and then after that we'll be meeting after 10 minutes and Sanjeev will be taking us further from this now. In the meanwhile, we will be opening Q&A. So if you have any question, you can go ahead and ask. Yeah, Sanjeev, you there?
Yeah, hi, sis.
Yeah, please go ahead and share your screen.
Yeah, uh, good morning, everyone. Good evening. So, thank you, Asis, for taking us through the journey for the Azure Event Grid and Azure Service Bus. I will be demoing how we can use in a real life application by using Microsoft SDKs. So let me share my screen. And okay. I think everyone can see my screen. Assis, can you just confirm?
Yep, it's visible.
Yeah, okay. So in the first lab, we will see how we can use the event grid in a .NET application and how we can see the events coming into the event grid. So for that, what we will do, we will first create a resource for the event grid. Then we will deploy a web app, and then we will connect it with a .NET application, and we'll see. So let's go ahead and do create one event grid topic. So you can click on the create resource and search for event grid topic. So here you can, if you select it, you can create an event grid topic, and what we can create a new resource group called PubSub events, and in the for the topic name we can give like HR topic. We can make it AG HR topic AZ-204. Then in the region, I will be taking it as STUS. And let's go ahead and check. Yeah. So in the event schema, we need to choose it as an event grid schema, and we can then do review. You will have different options, but I'm choosing event grid schema, which is by default chosen. So I'll go ahead and review and create it. Yeah. So it will take some time for the deployment because we are going to create one resource group and one. I think it's created. Let's go ahead and check if it is created. Yeah, our resource group is created. Yeah, and our event grid topic is also event grid is also created. So now what we will do, we will create a web app and put it inside the same resource group. So what we'll go ahead and do, we'll create a resource and we will search for web app. So we will take a basic web app, which is this one. And what we will do, we'll press the create button, and from here we will choose the resource group which we have created just now. And in the web app name, we will make it as an event viewer, because this web app we will use it to see the events. Event viewer AZ-204. So this is, we'll make it as take it as a Docker container, and operating system is Linux. We'll put it into STUS, and in the app service plan, we can make it as like event plan. So what we will do, we'll go to the Docker side. We will take it as Docker Hub. So I think we have covered a lot of thing about the containerization and how the Docker things work. So What I'm doing, I'm just taking a public image from the Docker Hub registry, which is a public registry, and I will be deploying that into my web app. So I have the URL with me, which gives me a Azure Event Grid Viewer application. So I will be putting it here. And I'll deploy this Docker image into my web app, and then I will use that as a web app application for my demo. You can put your application into this one, so there is nothing, because we have covered these things, so I'm not covering it anymore. But you can take your private image from the Docker container, or you can take the public one. But when you will be doing it yourself, so you have to, for demoing purpose, I'm using this one, but for a real life application, you need to create your own application and put it into in your Docker hub. So let me go ahead and create it. Yeah, it will take some time for the deployment. Let's see. We have to wait for the deployment to be finished. And once this is done, yeah, I think the app service plan is deployed. It will take a little bit of more time. Then we are good to go. So yeah, I think it is deployed. Let's see if it is working. So what we will do, we'll browse this application. Let's see if we get some response from this one. Yeah. So now if you see that there is nothing in this view. So what we will do, we will link this one with our event grid topic. So what we can do, we need to copy this one, copy this URL, because we need to use this into our event hub grid. So let's go to the resource group and for sub events. We have a chat topic. So what we can do, we need to make an event subscription. I think Ashish covered this on how this things works. So you need to click, you need to add the subscription over here. This is the event subscription button. You just press it. So you need to just in the name, you need to give I'll give it as a basic subscription. And this is event, and we need to put the endpoint type. For the endpoint type, I will put it as webhook, and here I'll put the endpoint, which I took it from here, and I will add one API to the end, being exposed by this this web app application, because we took it from the Docker container. So this already gives me the API updates, web API. So let's do it, and let's go ahead and check. Let's create it. I think it is created. If you see now, it has published one event into my event hub, so I can see the message. So if you see this, this is the message which has been published. If you see the last time, there was nothing, but now we have received one event. So now what we will do, we will create a .NET application which will be publishing some event to the event hub, and we will see how we can do it. So let's go ahead and create a .NET application. I'm not because I have a console application here in the .NET. So there is nothing. It's a simple console application which you can print hello world from here or something like that. And I will be extending this one to the to publish the messages into the event grid. So what you need to do, I think I have already, you need to install the Azure Messaging Event Grid over here so that you can use the respective NuGet package and the functionality of the Azure Event Grid over your application. So this is what I'm going to do. I will create the topic endpoint and the topic key over here to constant, which because I need to know where I need to publish the messages. So what I'll be doing, I will be creating two variables called the topic endpoint, which is, I will take it from the Azure portal, and another is my constant string. Another is my topic key, which is, let me keep it as empty. Then we need to record the topic key. So here is my access key. So this is the key. Let me keep it here. And this is my topic endpoint. So I need to copy it. I'll put it here. So now I need to connect with these endpoints, and I will be using this topic key to publish the emails into my event grid. So what I need to do, I need to create a URL where I can say where endpoint equals to new URI, and I'll set it as topic endpoint. What I can do, then I need to make Azure key credentials. I can say credential. I think I did. Let me read. Okay. So credential equals to new Azure key credential. This is the class which is inside your Azure namespace. So here I need to pass the topic key. So I will pass the topic key over here. Then what I need to do, I need to do event grid publisher client. I need this one. So I'll make it as event grid publisher client equals to new event grid publisher client, and we need to pass the endpoint and the credential, because by this way you can connect to your event grid. So once this is done, what we can do, we can just download the schema which we stored over here. Let me take it as like this. Now we need to publish the messages to, so for that we need to create a event. So what I will do event create event. So I can say first event equals to new event create event. So I downloaded the structure from there so that what we can do, I think this is the way. So I don't need these ones, ID and topic. So let's go ahead and subject, then data, then my event type. I need to remove. I just downloaded the schema from there so that we can. I don't need event time. And I don't need metadata version as well. I need this. So in the subject, what we can say, let's say new demo Sanjeev, and in the event type, what we can make it as, let me take it here. So in the event type, we can say so in the event type, we can say this is a event grid dot, I can say demo registration. Okay, then we can in the data we can send full name, like something Sanjeev P, and in the here we can send address. Let's keep it as this needs to be removed. This also needs to be removed. This would be, so let's put it as 800 South Wales, Illinois 60646. So let's say the data version, we'll keep it as let's say make it as 1.0. Think string subject event type data version and object data. And this would be new. Yes. Yeah. So this is the your event grid. You can set your event grid parameters which it takes. I just took the metadata and I used them. So you can just pass the data directly. Also, it's not required to send because I was just showing it to you. What are the types I am sending? That's why I was just showing it to you. Otherwise, you can just send the direct strings here because it's the parameters are taking it directly. So what we can do now, we can say await. We'll send it through our client. So we'll make it as client dot send event async. We can say first event. But the problem is we are using the asynchronous method, so we need to await it here. And if you want to await it, then you have, this is a normal method, so we cannot await in a normal method. We need to make it as an asynchronous method. So we need to convert it to async task. Yeah, so now we can say console write line event published. So we'll see if this works. Let's put a breakpoint over here and change this one to, let me change it to the startup project so that it can run from here. Okay, let's see if it is able to publish the event. Yeah, I think the event is published. We'll go to the portal and see. See, now the demo registration event is published, and you can see all the data which we sent from our application. So this is the basic way you can just use the event grid to send the events into your event grid topic. There are a lot of other things which we are not covering in this section, in the demo section, but I think Assis has covered a lot of things in the theory section. You can just play around with those things, and if you have any question, you can always ask in our Telegram group. Next, we will be seeing, like, we will be publishing some messages into the Azure Cube. So for that, let's go ahead. So for that, you need to create a storage account, but I already have a storage account in my async processor resource group. So you just need to create a basic storage account, nothing rocket science here. I think we have created a lot of storage account through our journey. So this is I have created a async storage account called async storage AZ-204. So if you see there is nothing inside in my, it's a blank storage account. I have done nothing. I have just created it. So let's go ahead and create a storage account. You can create it any time, but I have already created it. So let's see how we can publish messages into the storage account through an application. We'll develop a real-time application in our .NET code. You can use it any programming language because Microsoft supports a lot of programming language. So we'll see how we can create it. So let's go ahead, and I have a console application just here, which doesn't have anything. It's a blank .NET application. You need to install one NuGet package called, I think it's the storage queues. Yeah. So you need to install this storage queues NuGet package, or if you are doing it in Node.js, I think something npm, or in the Java, you can do it through the through your any package manager. So you just need to put this storage queues into your application, because you need to use this storage queues classes and all inside your application. So let's go ahead and start building the application and pushing the data into the message queue. So for that, what we will be doing, I'll be starting off with the code. So let's see what we can do. Okay. So the way we will be connecting to the storage account. For that, we need the storage connection string. First, we will create a queue inside our storage account. So for that, let me put it like this way: public. We'll make it as private constant string. And I'm writing it here, my storage account, storage connection string. I will copy the connection string from the storage account later on. Once my code is ready, I can just, and I will create a private constant. I need to create a queue first because we don't have, it's a blank storage account. We need to create a queue. So for that, I need a queue name. So I am writing, let's keep it as message queue. Okay. So like lot of the classes and all, there will be the methods will be in asynchronous programming. So we need to make the main method as an async one, because the synchronous one we won't be using. We need to. So after this one, we need to create a queue. So for that, the Azure Storage Queue NuGet package gives me I think the queue client. Yes. So we have a queue client. We can do we can create the object of queue client, and we can say new queue client, and we need to pass the storage account connection string. Then we need to pass the queue name. Then what we need to do, we need to just await client dot create async. So if I will create directly call the create async, my application won't wait here. I am making it awaitable so that it will wait here till the queue is created. And what we can say, we can just print the console.writeLine. What I can do, I can just do it here. Account metadata. Then what I can do, I can just check what is the account URI. So what I can do, account URI, I can make it as my client dot URI. So this is my URI for the queue which I just created. So let's go ahead and run it. So if you want to explore this storage account, Microsoft provides a storage explorer. If you click here, it just asks you to download the Azure Storage Explorer. I already have downloaded it and installed it. So I have once the storage explorer is with you, you can log in with your credential. I think it automatically picks up with your Visual Studio, but still, if you are not, then you need to add your credential, your Azure credential to the storage explorer, and it will automatically pick up which storage accounts are available. So if you'll see, I have storage accounts here, and in my subscription, you can see I have the storage accounts of this one, async storage AZ-204. So I have added those to the quick access. So here is my storage storage account. So if you'll see in my queue, I don't have anything for time being. So this is not the one. So I don't have anything in my queue. So once I will add the queue, I can see it here once I add it from my application. So let's go ahead and put a breakpoint here and see if, oh, sorry, I forgot to put the storage account connection string. So we need to record the connection string from the access keys. And so keys, then just copy this one, write the keys, then just put it here. So that's it. Now we can do one thing. We can make it as a startup project so that we can run it from here. So let's see if it creates a message queue inside my storage account. Yeah, I think it's already created. If you see, this queue is already there. Yeah. So now let's go to the Storage Explorer and see if it has a queue. It is taking a bit of time, or else we can see in the Azure portal itself. Yeah, if you see, this is already created. This one I created from the my console application itself. So now what we are going to do, we'll be reading the messages from the queue. So I think we don't need the queue these code anymore, because we already have created the queue, so that we don't need to keep it here, because our queue is already created. So we just need to read it from the queue, and we have the queue name and we have the connection string. So now we can connect to the queue directly. So I'm removing this code for time being. So I will be putting it as a, let's say, reading old message from the queue. Okay. So let's take a batch size of, you can read with a batch, like how many batch size you want to read at a time from the queue. So I will be keeping it as 10. Then I'll be taking a time span like visibility. So let's say add timeout equals to time span dot from seconds. I can say, let's give it 10 seconds. Okay. Now I need to read it from the messages equals to, I think we need to still make the queue client connection. Queue client equals to new queue client. We need to storage account connection string, comma, queue name. So here what we can do, we can await client dot receive. I think these methods and the classes are same across, almost similar across your programming environment. If you go to different programming world, but they are almost similar, the syntax and all. So we need to use await client dot receive message async. Yeah, we'll use this one, and we will send the batch size and visibility timeout. Well, not timeout. So we already read it from the queue. Then we need to look through it to show it into our this messages will keep hold of all your queue messages. So we will go ahead and create a for each loop. So let's go ahead and take it as message. In messages dot value, let's keep it as null check so that I don't break, and we can say that message dot message ID. And I can do one thing. Convert dot to base 64. So what happens? We need the messages which it gives you. It gives you in a encoded format. So we need to decode it to a base 64 base 64 string. So let me check base 64. So what I need to do, I need to decode so I need to encoding dot UTF-8 dot get string, and inside that I need to send convert dot to base 64. I'm doing this because your queue messages will be in encoded base 64 encoded format. I cannot show it because you people will think that the messages which are stored inside your application is different what I am showing it in my application. So that's why I'm just encoding it. So I'm decoding it. Yes. Message text. Oh, sorry, I need to use from base 64. Yeah. So now we will see. Let's go ahead and do one thing. I will try to run it and see if there is any message, but I don't think so. We have any messages over there. What we can do from the storage account, we can just refresh it. We have the message queue here. We can do what? Hello, AZ-204. So from the Storage Explorer, I am just adding it into the message queue. Let's see if we can read it. So let's go ahead and try to read it. Yeah, so if you see, it is giving me the message ID and it is printing into my console application. So this is the way, this is a sample code through which you can just read the messages from the message queues. So you can delete these messages also. What I can do, I can just add here. Whatever existing message is there, I will just delete it and I will add the new messages. So what I can do, I will do await client dot delete message async, and I can send message dot message ID, comma message dot opposite. So this way we can delete the message from the Storage Explorer as well. So now let's go ahead and if you see, I will refresh, the message is still there. So let's go ahead and check. Yeah, so the messages are deleted. Let's see. Now see, there is no message available inside my queue. Now we will see how to send one new message. So what we can do, this is a simple one. We can write adding new message, and what we can see, string, we can say string message equals to, let's say, we can type hello Assis. Then what we can do, we can just see await client dot send message async, and we need to do the same thing. Just a minute. We can do encode. Let me type it. So convert, I need to encode it to a base 64 string, then only I can send it to the message queue. So what I can do, convert it to base 64, and I can see encoding dot UTF-8 dot get bytes from my message. I think we need to weapons. Okay, now we can say message. Okay, so this part, it reads the message and deletes the message. So what I can do, for I already executed this one, so I'm just commenting out this code so that this doesn't get executed. And sorry, I need to comment on this file. Okay, so I think let's go ahead and run it, and we'll see if this works or not. Yeah, the message is sent. Let's go ahead and refresh the queue. Yeah, if you see, this message is already sent it over here. I think that's all from my side. Thank you everyone for cooperating us for such a long period of time. And I think you have enjoyed throughout this journey. And I think we have almost covered all the topics of 204, and we'll plan out for something else later on for the future. And Assis will be planning for something for the future sessions. And I'm signing off from the event for now. Thank you, Assis, for giving me this opportunity to share my experience and my knowledge to all the users who are watching our videos and taking part in this event. Thank you.
Thanks, Sanjeev. So yeah, thank you so much for sharing this, code-based practical, explanation, which is very rare if you see in many of the sessions that we see mostly from the certification exam point of view. So we really appreciate all our speakers and all the people that they actually cooperate with us to work on these sessions. So thank you so much for that. And with that, now I will share my screen for the next part, which is the quiz part, where we will be, having the quiz. Let me open the quiz for you guys. Just sharing the quiz link. Just saving it. Okay. Okay. So. Okay, so now you can see the URL for the quiz, and all you need to do is scan this code or open this URL in your browser. And I'm going to put this in the chat as well, so you can open it. And when you open this, you'll be getting a Microsoft form, Office form, and you need to complete the quiz there in next 10 minutes. So it's from 10 minutes from now, we are going to disable this link, and you just make sure that you kind of fill all the things in the quiz. So here's the URL or the scan code that you can directly scan in your mobile or any browser, and you can access the URL, or we have posted the link in the chat as well. Since this is the last session we have, so normally we announce the winner in the next session, but for this session, The winner we will be announcing later in our Telegram group. So if you're not part of our Telegram group, please join our Telegram group. We will be sharing the URL in the last slide. For the time being, go ahead and complete the quiz there. And we have like 10 minutes from now, so we expect you to finish this within 10 minutes. And then after 10 minutes, this URL will not be accessible. So it will ask you to log in, and also just make sure that you finish all the questions by that time. So it's yeah.
So to all the participants who are appearing this quiz, this timer is running, and we have 7 more minutes left for this particular quiz. Post that, this quiz link will be disabled, so you have 7 more minutes from now. The total time available for this quiz is 10 minutes, and 3 minutes is already passed. We have 7 more minutes. We have 5 more minutes left for this particular quiz. And meanwhile, just let me tell you once again, as Ashish said, for all our future session updates, for the recordings of all the sessions that we have done, in the past, and any new updates for the winner for the today's quiz. So for any such kind of updates, you can visit our website, that is azurez.com. The link for that is available in the Q&A chat window. There you will also find one Telegram group link, so you can join that Telegram group for any kind of update. You will have all the updates related to our upcoming sessions, the winner for these sessions, as well as in that Telegram group. If you have any kind of a technical query, technical doubt, you can ask those questions and talk to around 10K people across the world.
Okay. Yeah. So as Vipin has said, join our group to get updated with our latest content. And I was also, trying to highlight this aspect that if you find our sessions helpful, either in terms of certification or with the vouchers or with the training, or our community is helping in any either way, then just try to share it on social media and all. uh, the aspect that will help us to get recognition in terms of getting more benefits in terms of number of vouchers or any other things that we can pass it on to the community. These vouchers we are getting from Microsoft, so we are really thankful for them that they have recognized the efforts that we are putting, and they have also recognized the community member of our community, where they see that these vouchers are helping the community. So if it becomes more visible, then definitely it becomes a more easy way to kind of ask more vouchers, more benefits that can be passed on to the community, which can help or encourage people to learn Azure, or to kind of do the certification, do the training, and all those things. That's another aspect of the community work where where we want to get more benefits and pass it on to the community. All right, so I think.
So we have, yes, Ashish, we have 2 more minutes for the quiz, and yes, and the sharing to the social media, LinkedIn and other social media platforms, specifically the LinkedIn is the most popular professional platform. Once you feel like these sessions are helpful to you and you share it on the LinkedIn, it also helps the new people. Like it helped you as of now, and it will definitely help the many new people who wish to learn Azure technology. So it's all these sessions are, the motive for all these sessions are actually a community service. Okay, so we just want to help more and more people. So that's why we encourage not to hold it this information or this thing to you only, and but we will encourage to share it more and more to many and many people. So we have a last 1 minute now, Ashish.
Okay, so hurry up, guys. If you are in one of the final one, just select whatever you think would be the correct one, because many times we have seen that people do, complain that by the time they are submitting the quiz, it gets expired. So you don't want to be in that particular guy. So just make sure you submit it. Yeah.
Ashish, time up, so we can disable the link now.
Okay, so now it's disabled, and yep, it's disabled now. So now if you access this link, it's not visible to you. So just make sure that you have already submitted. Now let me share my screen again. I mean, let me share the list of people who participated last time. Just give me a minute. I'm sharing my screen. Okay, so okay, so just give me a moment, guys. I am opening the correct list. Okay, so these are the guys. We have it from the list of people who have participated last time. I hope the screen is visible. Yeah. So we are going to run this wheel now. And, okay, so Ganesh, congratulations. You'll be getting a voucher email soon. And yep. So Pooja Tyagi, congratulations. You are the next one. Okay. This is Mohsin. Congratulations, you will be getting a voucher. Akshay, congratulations. So let's see. Last. It's Justin. Congratulations, Justin. Okay, so now will be the next one. And it's Manohara. So that being the last for the voucher, and this will be the last winner for book as well as voucher. So we are giving a voucher as well to the book winner. That will be Sandeepan. Yep. Congratulations, Sandeepan. I'll be soon sending you an email with the details of the voucher as well as the book details for the book winners. These are the people who were lucky for this session, and then similar thing I'll be doing it since the next session will not be there, so probably we will be not announcing it in the next session for the time being, but the winner will be announced in our group. So if you are part of our group already, then you will be getting to know, or I'll be sending you an email, or just make sure that you are part of our Telegram group. Then your name will be, we will be posting the name as soon as we will send the email, so that just in case if you are not getting the email, then you just connect with us and we'll try to check what happened. Just in case we missed the name or we sent it to the wrong email or something like that. So with that, this is our last session for this series. Thank you so much, as you have been very patient enough, and we have been trying to share the knowledge that we have. So if you want to share your feedback, You can always share your feedback on our YouTube channel or in our group or whatsoever you think we can improve upon in terms of session, in terms of topic and all. So definitely please share those feedback and we will try to improve on those things in our upcoming session. Talking about upcoming session, we are planning to have sessions on architecture now. So if you are already connected with us, then you must be knowing that we have already done Azure Fundamental, Azure Administration, Azure Developer, and now Azure DevOps, these tracks. And now we are planning to have some session revolving around Azure architecture, which is the next step towards getting the expertise in this cloud, Azure cloud. The Azure architecture theme will be a little bit different than the themes that we have been doing for other tracks, because as you know, the Azure architecture is a very comprehensive topic. So there will be a little bit of different pattern or theme that we are going to come in the next series, and we'll be soon announcing the series details, the architecture series that we are going to start, when we are going to start, what topic we are going to start with, all those things in our group, in our Azure Talk Telegram group or Azure DevOps group. So if you are not part of that and if you are looking forward for those events, then please join us. Apart from those Azure architecture track, we are also trying to talk to people, and if you are one of the speakers that you want to be or you want to work with us, definitely reach out to me in the group, or you can send me an email, or you can connect with me on LinkedIn, and let's see how we can kind of come up with new speakers in the community. So that is also something we are looking forward. So Azure architecture track coming soon, very soon. As soon as we are getting, as soon as we will complete this session, we are going to, connect back with all our core team members, and we are going to plan on it. And we will be definitely coming with some exciting events or some exciting topic around architecture, both from the theory as well as from the practical aspect. The second thing is that we are also trying to see how we can bring in more speakers from the community itself, those who are experienced in different aspects of Azure or something else, and they want to share their knowledge with the community. So if you are one of them, reach out to me and we will work together to figure it out how we can make this community more, more diverse, more active, and more helpful towards everyone. With that, thank you so much for for helping us with conducting this session. And thank you so much for joining these sessions for these so long durations, like 3 hours is not it's not a small duration to join any session, but I am really thankful to all the audience as well as speakers, those who has been always kind of work with us to make this successful. Thank you so much. Have a good day. Have a good night wherever you are, and join our community. We are soon coming back with some more exciting events where we are going to share more knowledge. We are going to learn more things together. With this kind of interactive session. Thank you so much. Have a good night. Have a good day. Bye bye.